Welcome to the Denver Erlang and Elixir meetup. If you're joining on YouTube, this is for Monday, August 7th, 2023. The meetup tonight is sponsored by Praxeal.io. If your company is using Elixir in production, Praxeal.io secures Elixir in Phoenix. If there's any help you need with security, from pen testing, compliance to developer training, please reach out and talk to us. We'd be happy to hear from you. I should also mention that myself, Michael Lubis, I'm giving a training at ElixirConf this year, September 1st, on Elixir security. So you still have some time to sign up if you'd like to. Just go to the ElixirConf website. And now for the main event, Down the Rabbit Hole with Next LS by Mitch. I actually saw Mitch in person at Codebeam last year, and he's done some incredible work for the Elixir community. Really fantastic to have him speaking tonight. So I'm going to stop sharing my screen.
This works.
Can
you see a text editor? Okay. Let me get this. There we go. Okay.
Perfect.
Awesome. Yeah. Thanks again to Michael for inviting me. It really means a lot. And I'm seeing a lot of names and usernames and such that I've recognized from online and in person. So good to see you all again. A little bit about me. I skipped the introduction because I was going to do it here anyways, but my name is Mitch Hanberg. I'm the guy on the right. If it wasn't obvious, the other guy's my dad. I'm based in Indianapolis, Indiana. I've been working with Elixir since 2017, and as I like to say, I went pro in 2020. Started at Bleacher Report 2 weeks before the pandemic started. So started a new remote job, and then the whole world went remote. Nowadays, I'm a senior engineer at SimpleBet. Used to work with Rudolph, who just introduced himself here, so good to see him again. And sort of the other parts of the Elixir ecosystem that I've kind of been heavily involved in are I'm the maintainer of Wallaby, one of the two browser system feature acceptance testing frameworks. And I'm also the author of an HTML and component DSL called Temple. So down the rabbit hole, the story of NextLS. So here we'll sort of we'll do a rundown of kind of what led to NextLS and sort of have a little bit of a walkthrough of kind of how it all works. Because I think these language servers and code intelligence can seem really daunting to a lot of people, especially if they've tried to do some source diving of Elixir LS, for example, or other ones like Go Please or Rust Analyzer, just LSPs for other languages. So to start it all off, NextLS is a member of the Elixir Tools family of packages and developer tooling for Elixir developers. It is sort of the umbrella organization that has language servers, editor extensions, libraries, and it's founded by me. Here you can see a photo I took at Gig City Elixir conference with the Elixir Tools sticker that I handed out to everyone who asked and didn't ask. So little recap before we kind of dive into the rabbit hole. In April, I sort of announced this to the world. I released the first version of the Credo language server. So Credo language server is a dedicated language server for running Credo against your code base. I gave a talk at Codebeam America in November of 2022 about OTP process abstractions, and it kind of goes over the basis of how I wrote the library, the framework that I used to write Credo language server. And kind of at this, I formally announced the Elixir Tools organization. In July, took it a step further, released the first public version of NextLS. It came with quite a few features: compiler diagnostics, code formatting, symbols, and go-to definition. These were kind of the features that, other than auto-completion, These are kind of the features that I kind of saw as necessary for a first public release, and mostly just the things that you like to use a lot. So cut my teeth, is that a phrase, on these features and made the first public release, and also built the elixirtools.dev website. So this is just a screenshot of the first introductory blog post on that website, and kind of went over big recap of everything that's happened so far and what's next, and introducing Next.ls. So let's kind of dive into this rabbit hole now. So around a year ago, well, more than a year ago now, probably last May or March, I can't really remember, I grew some frustrations with the existing status quo of Elixir developer tooling, be it in-editor tooling, anything you're going to be running in a CLI, that kind of thing. And I figured that if I wanted to help it, I could either do my own thing, or I could contribute to the existing tools in the ecosystem. And I did a little bit of contributing, and I also just decided that the way I personally can make the biggest impact is if I took again, I don't know if this route, I took a whole hog sort of approach to this, and I was going to go about it with the highest quality, best experience that anyone's ever had. So I started, going about it, and I say, well, we're all used to using like Phoenix and Ecto and stuff, and it's like, well, this would be easier if there was just a LSP framework, So I start working on that. It's like, well, I start working on that. I'm like, well, I might as well generate the framework from the language server protocol JSON specification if I want it to be, accurate. And there's a lot of stuff, so I didn't really want to type all that from hand. So I start doing that. I think, well, it's kind of hard to represent all this TypeScript-esque types, because it's a JSON protocol, but the way they present it to you is in this pseudo TypeScript syntax. It's kind of hard to represent that in Elixir because it has sort of a gradual structural type system that's kind of hard just to, and also our types are just, they'll just give you a hint if it works or not. So I guess I need to build my own data serialization, deserialization library, as one does. So that's the bottom of this rabbit hole, and let's sort of climb back out. So from the bottom, I built this library called Schematic. I built this other, it's kind of a library. It's more just like a really extensive script type thing. I mean, it's not just a script, but it's not really, you don't want to go look at that. It's not interesting. Then I built Gen LSP. That's the framework used for making language servers, is what I used to build Next.ls and Credo language server. It's what was the impetus for the talk that I gave at Codebeam. And then now we have Next.ls. So Schematic, let's go over this a little bit. It's a library for data specification, validation, and transformation. Here's its logo. I didn't make this. AI and machine learning made this for me. It's similar to Norm if you're familiar with that. Norm didn't fit my use case exactly, so let's take a quick peek at Schematic. So this is the README for Schematic. It's sort of a ad hoc type specification built through protocols and structs and functions. So at the basis, we have primitives, we have bools, strings, integers, floats, lists, tuples, maps, schemas, which are structs. Just there's already you use this library by importing it, and there's already a function called struct, so I call it schema. There's raw, any, all, and one of. So kind of what it looks like. Here's the example, and these are all actually pulled into doc tests as well. You basically, you can just write functions and just do whatever you want with it, but sort of the convention I've proposed is you make a module, you give it a a function called schematic. It can be called wherever you want, and here's where you define your data and how you want to serialize and then also deserialize it. So we'll skip the raw one to begin with because it's a little more complicated. But so for here example, we define an author struct, and then when we define the schematic, we say this is a schema, and we give it a blueprint. So here we're going to say this is going to have a key of name, and it's going to be any string. Here we get a little more complicated. It can show a little more of the things that schematic can do. Here we have another struct, we have a schema, but here we're dealing with this bookstore API, and it uses camel case for a lot of its keys. And we're Elixir, and we like atoms, and we like snake case. So here, and this is so it's not like magical. It is sort of explicit here, but you can give it this tuple syntax in the blueprint to say, I'm going to parse this string key of publication date, camel case, and that's the from. And then when we go to, we're going to turn it into snake case atom, but it could be anything. We could type the number 2. It could be whatever. And then this needs to conform to the date time schematic. That was that raw one we saw up there. So then here we have title and authors. Authors is a list of author schematics. Here, just as some sugar, if you just give it a string, or if you just give it an atom key, it will automatically, since this is a schema, it'll automatically do string to atom conversion there. So here we have a couple more. See, we have book list params. It's another struct. Here we say this one can have a query, but this one actually can be nullable, so it can be nil or whatever this thing is. It's a map, so we're not going to turn this one into a struct. It's just going to go from JavaScript object to map. Here we explicitly set the map schematic does not do automatic string atom conversion. So here we explicitly say those. We give a little one of that's kind of like title or authors or publication date, and just another value. And that's just sort of how schematic kind of works. And in the end, you unify this. So we have our top level schematic, and then we give it some input data, and we can, by default, we will serialize this from the external data into our internal data. And here you can see it can becomes a struct. Everything's converted top down. And we can also dump our internal data model from structs and whatnot to external data. So in this case, it's still an Elixir map, but you then, pass that to JSON to decode. But so here we have a book list result. It's got list of books. Here you can see we've got a UTC datetime is an Elixir data structure there. And then when we dump it, it turns into a ISO whatever string and turns everything to the publication date. Goes from an atom and snake key goes to that. So that is sort of schematic and how it works a little bit. So if we move forward, the next thing is LSP Code Gen. So this is the library that will read the metamodel.json file that Microsoft has for the language server protocol. We read that. Well, so technically there's a metamodel schema. There's a JSON schema specification. I kind of just hand wrote code to follow that. And then we use that to read the metamodel and generate all these files. This is very similar to, there's a Beam Elixir, or no, that doesn't make sense. AWS Beam organization that has some AWS Elixir and Erlang libraries are generated from their protocols. Very similar process that they do. So the reason why I went with this sort of code gen rather than macros is the compile time just ends up being way faster when I'm like trying to change things, because when you need to change like one small file, you're not you're not changing a single Elixir file that writes a gajillion modules, so it's not going to have to regenerate the whole project, and it's just easier to audit in diff when you make changes. So here we'll take a little look at that. So LSP Code Gen. So this, like I said, it's mostly just a script. I literally run it like this: elixir-e mix install it from GitHub, and then just call a function and just pass in a path. And then, my automation is just a curl thing in the README. But so this code is basically just, we are going to read this meta model, decode it into Elixir, and then it's more or less just there's a meta model, and then that kind of like parses the whole thing into Elixir data structures. And then we more or less just walk it and then use a combination of Elixir protocols to turn this into various things. So like when we're going to render the requests, we just have a EEX file that just, gen LSP requests. We have this naming functions. If there's documentation, we put it in there. I'm using type struct here, so it just makes it really easy to generate the Erlang specs, so it can be dialyzed and whatnot. And then here you can also see we have our schematic. These are all requests have a method, a arbitrary JSON RPC string, and then an ID and some params. So here, if we actually, what is this code? I think this is in code gen dot. This project is a little ad hoc, but yeah. So here this is some of the code for determining how to render this into the string to put in this file. So if we go to like structure literal, is this it? Yes. So here we have implementation for code gen that kind of does the Erlang types, and then here we have the schematic implementation, and here we go into a structure literal EX file, and I mean, there's not really much to it. It's just looping over the things and just typing it in Elixir code and whatnot. So it's not super interesting, but that's how generate the gen LSP. So move forward, that'll be a little more interesting here. So gen LSP, it's an OTP behavior for building processes. They implement the language server protocol. It handles all of the IO that involves talking to the editor. So you just don't have to worry about that at all. You basically just create a module that implements this behavior, implement the callbacks, very similar to a gen server, and then it will, since we have all these structs that are all generated and validated, ingoing and outgoing, you just never have to worry about your LSP server not adhering to the protocol. And then you have like the NeoVim core team. You have someone complain to NeoVim saying this doesn't work, and then they say, well, that LSP is actually wrong. They need to fix it because we're not going to like make all these one-offs. You just avoid all that. It just works. If anything, throughout this process, I've got an Emacs guy in our Discord who's been extremely helpful trying to get everything running on Emacs. And he's actually found a core Emacs bug, and he submitted a patch for it and several other Emacs library bug fixes. So it almost kind of like fuzzes LSP clients. It's kind of interesting. So yeah, I gave talk about this. It's mostly about making OTP compliant processes like a gen server rather than just wrapping a gen server. So like a Phoenix channel that wraps a gen server rather than being its own type of process thing. So then, like I said, I use gen LSP to implement creative language server and NextLS. So we'll just take a quick peek at gen LSP. Like I said, this is just the README. So what's a good place to start? So here you can actually just see these are all the files that are generated by LSP Code Gen. So here, if we just want to look at, let's look at document symbols. So here we, did I text document symbol? Okay, so here's a request, text document symbol. That's a thing that if I move this zoom thing, you can see up here at the top of my editor, these breadcrumbs. That is what powers the breadcrumbs and does things like this symbol. So if I toggle the symbol outline, it gives you all these things, very similar. You've probably seen this in VS Code. And then I can also open them in a fuzzy finder window like this, and they kind of have a hierarchy. But so that's just explaining what that is. I really like it. Use it all the time. Here we can see the schematic, and we have a schematic for parsing it and also for the result. So here you can see the result is one of, it's either, basically all of these are either an error response, or in this case, it is a list of symbol information, a list of document symbols, or nil. So here we can pop, oh, well, that's not good. Oh, I had a swap file problem there. I quit all my Vim instances earlier, but yeah, that's more or less what it looks like. So let's see with that cursor position outside of buffer. Yeah, that's not good. Yeah, so that's what that is. Let's go back to over here. And that brings us to NextLS. This is aspirational. It is what I want to exist. So the tagline is the language server for Elixir that just works. And we are now ready for early adopters. So we'll take a look at kind of the guts of NextLS a little bit. Look at the LSP process. We'll look at the test framework that comes with Gen LSP, and we'll kind of take a peek at the TCP mode, which is part of the language server specification, but I find to be it's not every language server implements it, and Elixir LS doesn't implement it. At least it didn't a year ago when I started on this whole thing. So, and I have not used it in quite a while at this point. But we'll take a look at that. So here we can go to NextLS. I was using this earlier. So here, oh no, actually before we do this, I wanted to show this. So here I have this cool Elixir community. We're really into mermaid diagrams now. So I made this mermaid diagram of the supervision tree, and I think it's kind of neat. So the NextLS is it's a supervised application. So we have our application that basically just starts another supervisor called LSP supervisor. Here, it kind of controls everything. We've just got a couple task supervisors. We've got the Gen LSP buffer. That's a thing. You got to start it, but you don't really have to worry about it. We've got our diagnostics cache. We've got registry, like in the standard library registry. We've got a dynamic supervisor, and then we have the actual NextLS process. The NextLS at the LSP process, and that is what, as the editor, is sending you requests and notifications. Those messages are being sent to this process, and it's executing the callbacks that we'll get into in a second, but it is what's doing the bulk of the work and doing all the coordination. When NextLS is booting up and you open your first Elixir file, the editor basically initializes, and it has this concept of workspace folders. So if you use VS Code, you can probably know where it says like you open a file and click like add folder to workspace, and basically allows you to have a bunch of root projects open in the same editor. And they actually will use, if your LSP server supports workspace folders, it will actually, it'll open one NextLS instance instead of a bunch of them, which can be good. Probably will minimize memory usage and stuff like that. But for each one, this is where a dynamic supervisor comes in. We basically start a runtime supervisor for every single workspace folder. A lot of the times you're going to have a single workspace folder. So it's going to start one. It starts the runtime process. That basically is main job is to start a Beam instance of your project in a port. It doesn't start it like it doesn't start any of your applications or anything. It's more or less just getting to the point where Elixir will load your code into the code paths so that when you send messages to it, you can ask about it. We have a little sidecar process that's basically just so we can shovel messages from the runtime process over to it rather than bottleneck the runtime process, because we want like compilation logs and those are sent out of the port. We don't want to, like, if we ask the runtime a question via message, we don't want it to not be sending those to the LSP process. So little sidecar process. And we also have a database process. So this is relatively new. And I think it's pretty neat. Originally, Next.ls used DETs, so DETS, so the like durable version of an ETS table. But you write a lot of match specs, and those are kind of hard to write and definitely kind of hard to read. And there's still kind of performance implications. So I ended up switching to using SQLite, and there's an amazing Erlang library called, I call it SQLite 3, but it's like ESQLite 3. That you just open the SQLite file, it starts a process, and it's just linked there. So that's pretty. We have a database for each runtime that gets started. And then here you can see we have extensions. Currently there is only an Elixir extension. It's basically extensions are broadcast to. The compiler diagnostics are broadcast to an extension. An extension can do what it wants with that. And currently we have the Elixir extension. So it's the thing that handles turning the Elixir compiler diagnostics into like LSP diagnostics. And we also start, it's for every extent. There's one extension, like one Elixir extension for everything. But in the future, going to put Credo language server out of business, in that I'm going to make a Credo extension. There's going to be a dialyzer extension. And then hopefully down the line, I've been in touch with a couple of the folks behind Ash Framework, and they already have an Elixir Sense extension, which Elixir LS uses, but they're kind of interested in having a little more power and flexibility. So I'm going to be working closely with them to see what a library kind of would need out of an LSP extension. So that is the supervision tree. This all works pretty well. Just thought it was also cool just to put it in a little mermaid diagram. So we'll pop back into the code here, and we will start with, we'll kind of just dive through this. So here in the bottom, actually, you can see Next.ls it initialized, finished compiling. Here we can look at the, I guess one thing I forgot to say is we boot up your runtime and it's on Elixir node, and then we actually use distributed Erlang to connect to it and do message passing. So here we booted the runtimes. There's only one. It's ready and it's compiled. So here we have LSP supervisor. We use a little go-to definition there. Here that just kind of handles some of the command line options. And here we, start all of the business. So here we we'll jump into the actual LSP process here, which is Next.ls. And one thing I'll just kind of note, in that I try and do this and makes testing really easy, is I always pass in, instead of just like we give our dynamic supervisor a name, instead of just hard coding that everywhere it uses it, we actually pass it in to the process. And then that just enables you in tests to be able to start as many of them as you want, and it just knows which one it needs to talk to. So we kind of jump in there. Here we have a whole mess of aliases that take up a lot of space, and I'm not really sure what to do about that. But we start this process. We say use gen LSP. The same thing as like use gen server. So we'll pop up here, start link. We take our things, we pass it in. We have our init. This is one of our callbacks. This is basically just a ton of boilerplate that accepts those options, and it's boilerplate, but I like it because it means you get some little safety in your tests of having to pass everything. So we start a little logger process, and then here our main token is very similar to the con or the socket. We have the LSP token here, and we can call a sign on it. Basically, this is just all state, and then here is the business. So our callbacks that Gen LSP provides are handle request, handle notification, and handle info. And we can use these to accept these requests, and they're passed all the structs and everything that are parsed by Gen LSP. And we pattern match on these to know which message that we're doing. And eventually the idea is there's going to be either it'll just kind of work out of the box because they're all structs and it should be cool, but I potentially will have a next ls extension so that when you're typing these and you type params, like, so if I'm typing here and I start to type P, it'll know, oh, we're auto completing struct field. So like IEX can already do that. Like that's going to be able to work. But then hopefully also it'll know, oh, this is typed as initialized params, and you can do a snippet to do all that. So in the future, I hope that is kind of what happens there. Oh yeah, we had this is a compiler error there. And then now we're back in business. Yep, you can see our ginormous breadcrumb there at the top. But so here, this is when the editor sends the client initialize request, has the workspace folders, the capabilities that the client can do. If they support workspace folders, we take that out of that. And then this kind of just returns and tells the editor what we can accept, which in this case, it's formatting, symbols, references. Oh, it's a little sneak peek, definition, and workspaces. So, and then at that point, you just basically can pattern match on any of the requests. And here, if I do the document symbols, you can kind of give an overview of all the functions and everything in here. And based on your editor, this is using a NeoVim plugin called Fuzzy Find Lua. It gives you this little completion or preview and whatnot. But so basically this takes in the requests, and then what we kind of do here is so handle notification, then did save. So here, when they save a file, that indicates to the LSP, we need to recompile, right? So kind of what we do is, this is why we have these task supervisors. We stop them. We stop those processes that are in flight, and then we kind of restart it. And here I just have a little wrapper around it, but we basically use registry and dispatch to any of the runtimes that are open, and we send it some messages. So basically we start this in a task supervised async no link, which I love actually in a little bit, and we send a message to the runtime. Here we kind of have a specific one compile. So that's not fun. It's not working. But we can jump over here, compile, handle call, compile. And here we have another one. This is so we can start this compile in another process, so then the logs don't get all blocked and everything. But here you might notice we have RPC, and this is the distributed Erlang talking between nodes, and we have this strange syntax here. Well, what happens when we initialize the runtime? So we register this process as one of the runtimes, and what we're actually doing is we open this port, and we basically call Elixir no halt, give it a name, and then we call mix load paths no compile. And So this boots up your project, and we kind of inject some values through environment variables. Here you can even see we're literally taking this process, or maybe it's the parent process, term to binary based in code 64 it, and then we're sending it over that way. And so once our node is up, what we actually do is more or less monkey patch it. So if we go to this file, this is not like part of the project per se. It's just a file that includes a compiler tracer and this little module here. And I kind of prefix it in this way just so I know like this is an XLS private thing. But basically send it there. We change around some group leader stuff just so the standard out like stays on this node. And then we just recompile and, or sorry, no. First, what we do is we fetch this out of the privdir and we do an RPC call to your runtime node, and we just call normal code.compile file, and we give it this file, and it compiles this file on your node. So then when we want to compile that node, we can just call this function that is now lives over there. And then also see when we do this, we pass it a tracer, which we're doing up here. And the tracing is what kind of populates the database that SQLite reads. But so that's kind of just how the LSP process sort of works. We have our callbacks, we take in those messages, and then we can send messages to the user's project runtimes and ask it to do things like compile, or once I have the Credo extension, you'll be able to say, like, oh, run Credo in your node. And because it's doing that, Credo doesn't have to actually live, like all these library extensions, I don't have to, I mean, I'll probably want them in the test environment of NextLS so I can test them, but it's not like going to be bringing in all these packages when you install NextLS. It will detect if they are present in your runtime, and it will run that code. So like I said, that's a little bit of the process runtime or the LSP process. So let's take a look at the test framework. So currently just have more or less a ginormous integration test file. And here we import gen LSP test. That's the test test library. And I will open up, you can't see it on the screen I'm sharing, but I'll move it over. But since this is, a library, it incorporates with one of my favorite tools, Dash, for documentation. So I can actually pull that up right now. Yep, here we go. So this is the gen LSP test. We've got a couple functions, see if your thing's alive. You can make a new client. So like, we're not actually starting a text editor, so we have kind of our own little client here. You can send notifications from the client to the server. You can send requests to the server. And then this is how you boot up your server. And then we have some macros, and these are more or less wrappers on the assert receive macro. And they work like they literally call it. They just, cover up some boilerplate. But so the way the testing framework works is we send a message, and then the LSP is actually sending the messages to the test process. So when you want to assert on a result, you're under the hood. This is assert receiving, on the process mailbox. So you basically just pattern match on the ID to say like, okay, I want to assert on the result of this, because when you send a request, you give it an ID, and that just tells you when you can correlate the request and response, basically. Same thing with notification. You can just assert on. So in this case, it's obviously not a synchronous issue. It's just, I know that my server will log this thing, and I want to assert that it's being logged, and that's being sent through a notification. So you can just assert that this notification was sent. There are assert errors, when that happens, and also asserting on requests. So like the server can also request stuff from the client. So for example, some capabilities are dynamic. So you don't, when you do that initial handshake and you communicate what you are capable of, meaning the server or the client, there are some things that are dynamic. So you can say, oh, I want to actually register this capability at runtime. So that poses a problem of if server is going to send the client a message, but most of the time your client is NeoVim or VS Code, and obviously they have responses to those things, but this is just all in your test. So here, this is in my head, it's kind of similar to like bypass, where you can assert, we wait for this message to come in, and then we just call this function with the params that it was, and you can, make assertions on that. So if we actually look here, we can see some of this in action. We just write whatever test files we want to a temporary directory, just so every test can kind of be its own thing. We don't have like one massive test file that, every time you make a tweak to it, you got to change like 10,000 tests. So here is, let's find a cool one. Here, publishes diagnostics once the client has initialized. So here we notify to the server that we've initialized. Some boilerplate, have to do that. And then here we can actually, I assert on these progress and log notifications as almost like a way to know that the server is like ready, and because this is all like asynchronous, like testing and everything. So basically just testing on all of these, and then once it is all compiled and everything, we're asserting on that the server has sent us these diagnostics. So the diagnostics are like warnings and compiler errors. So we can do the same thing with formatting. Here we say we're notifying the server that we opened a file, has these contents. Then we request to the server that we want to format that document. We give it a URI, some options. A lot of these requests just all can return nil. But so here we are asserting that our project is not compiled yet. So if you are trying to format something, because we're going to ask your runtime to compile it. So it just definitely works with your formatter config, all of your plugins and all that kind of stuff. But we don't want it to break if that is there. So just return nil if it can't do it. And then now we know the project is ready. So we do it again, and we can assert the result is this new text that's beautifully formatted. And then, that it properly tells it where it needs to go and everything like that. So that's sort of the test framework. So, I wrote it all. So obviously I'm going to think it's nice, but so far it is made. Writing these tests, because this is definitely a sort of project where you might do all these manual tests and manual regression stuff, and you get really out of hand, really tedious to write these tests. So having this testing framework is definitely a must-have for making this just manageable. And next thing, kind of transitions from this nice, is the TCP mode. And because normally a language server communicates over standard IO. So your text editor just runs like next ls space -- standard IO, and then it just will send standard IO there, and then your project slurps that up, does some stuff, and it puts stuff to standard out, and it reads from that. And that can get really hairy for just writing these tests, because we're already going to have to boot up. These tests are actually going to be booting up a runtime. So it's like, oh, you have to have this project boot up itself, and then that boots up another thing, and that's just going to get crazy. So the test framework actually uses the TCP mode, and that just makes it really easy for you can boot up multiple servers. They can be on different ports, talk to each other. And the TCP mode makes it, and so this editor stuff, an editor is visual, and it I mean, when I'm starting to implement this, a lot of the stuff, it puts a smile on your face, and it's really cool once you like actually see it working in the editor. So you do want to like be, a lot of the times you're not doing test driven development because it's kind of hard with all these like character and line, like that's not, it's hard to focus on that. So you're going to want to run a local version really easily and be able to restart and blah blah blah. So being able to connect to this over TCP is really great. So my Elixir Tools NeoVim plugin makes it really easy to connect that way. And with the VS Code plugin as well, you can switch it to TCP mode. And I'll show you an example of how that kind of works right now. So on this right, I just have this little script here that just starts it. So boot that up. It has IEX. Here we can see starting in port 9000. And then I have a little shortcut here where I say next.ls local, and then I can boot up this file. And this also makes it really helpful for if you want to print out like IO inspects or debug. Normally those get sent to standard out, and then that just clobbers the text editor because it's not an JSON RPC message. It's really confused. So here you can actually, it will print those to the console on the right, and you can use IEX like step debugging if you want, or just print things out. When you're not doing that, it's not gonna, unless something goes horribly wrong, you're not really gonna see anything there. But this will demonstrate. So today, big shout out to I think his name's Christian. Merged a PR from him that implements find references. So it's kind of the inverse of go-to definition. Those go-to definition, I click on that reference, and it brought me to this definition. But and the reason why I'm saying I can demonstrate this, because this is not released yet. So it's only available here locally. So then now I can do this. Well, this one's only used in one place, so it's not very fun. But if I do this one, for example, this shows you all the spots that function was called. And you can do the same thing with modules. Here you can see these other two that are not the same thing. See this one, it's only called there. And this is just a fun side effect of how everything works, but you can do it with just literally anything else either. So this is all the place that keyword.fetch bang is called. I'm going to call keyword by itself. Yeah, here keyword.take, it's there. So that was an absolutely awesome contribution. And I mean, it's hard to talk about your own stuff without feeling like you're tooting your own horn, but this person was able to implement this in including tests in like 200 lines of code. They started it 2 days. Well, they live in Europe, I believe. So the cycle is always delayed, but implemented it like 2 days ago, tested it today at their day job, and then marked it ready for review. And I looked at it, and it was literally, actually, let's see if I can even
yeah, just so you know, it looks like he's in Spain.
Spain.
So,
yep.
Yeah.
Oh, yep. Here he is. So find references here. Literally plus 207 minus 0, which you might think like, oh, when you're working on big legacy code bases, you want your pull request to always be net negative, right? Because there's probably a lot of cruft and tech debt. But on a newer project, from like what I like to see is this was purely additive. Didn't have to like change like I don't even know if I'm using all these terms right, but like it was literally just needed to add some code, and it enabled this entire new feature. And I think that is a direct testament to the design of the LSP library and the testing. And also, to be honest, this was the first feature added after I switched over to SQLite. And a lot of us are web developers, and web developers write SQL a lot. So I think that also had a lot to it. But huge shout out here to Christian Alvarez, last name. Tremendous PR here. Total beast mode, as I said somewhere in here. But yeah, so I think that kind of wraps it up on our brief little tour. Like I said, this is the rabbit hole, could talk about it for a million years. We'll kind of wrap it up there. So I'll say what's next. Get it? Things I'm going to be working on next are a binary executable. Currently, the distribution model for NextLS uses mix install. So like each text editor and the releases page on GitHub has an Elixir script. So like a shebang env Elixir, and then that calls mix install, does some stuff, and then starts it, which is great. But it just kind of relies on a lot of, it's still going to be running it on your version of Elixir, but really because of the runtime separation that I've done here, I want to be able to use whatever the latest greatest Elixir is, just like you do it with your app at home. Like I want it to just use OTP 26. I just want it to use Elixir 115. And using a library like Burrito, which I use on this other project I wrote called Lazy ASDF. We can talk about that later if you'd like. That can wrap up your project into this single, it's not technically a binary executable, it's a single executable, and it kind of auto extracts itself, and it has its own Erlang runtime, and you can just package it there. And then it'll just, when it boots your app, it'll boot it in your version of Elixir that you have installed. But for this, it'll be a single thing. It can be easily put on Homebrew, Arch, Debian, trying to sound like I'm a cool Linux guy, any of those package managers. And I think that'll solve a lot of problems just with people not, with troubleshooting people's problems. The next big one is completions. Hope to get very basic version of that, or maybe even just snippets, so not even like real auto completion, but just like a snippet for def and def module and that kind of stuff. And then refactoring tools. And other than a lot of the guts and just the like the reliability and robustness that I think I'm already starting to bring to the table with Gen LSP and the testing and such, the first real innovation with NextLS will be some more of these refactoring tools like extract variable, extract function, rename, all that kind of stuff. So that's going to be the first real cool innovation where I think the people who are not, like I'm making a code intelligence tool, use NeoVim, tmux. Like I'm like one of those nerds who's really into this. So, but for the people that just don't care about any of that and just need a good tool to do the job, these refactoring tools, I think, are going to be what makes them see the difference between NextLS and the existing status quo. So I'm going to be really excited to get cracking on that. And a quick shell, but I have GitHub sponsors. I have quite a few, and I'm very, very grateful. Individual GitHub sponsors, but I would really love it if I could get some corporate sponsorships. So corporate backing, by companies that want to accelerate their developers, take the burden off of individuals who are just really enthusiastic and put it on their companies that probably have lots of money to burn, hopefully, because you're using Elixir, right? So your product is probably really good and you make tons of money. So give me some of that. And then you can either sponsor me on GitHub or contact me to discuss some other type of thing. And there's the link, and that's it.